event in October, but it's the talks that we've been doing for quite a lot. Hello. I'd like to thank all the members, supporters of the Engineering Club, which some of you will know. We have, I think, 3 or 4 new members already. So welcome DDA engineers, London Structures Lab, and McBain's. Who is anyone here from any of those organisations tonight? No, they still haven't got themselves embedded in the club. But very big welcome to them, and a big thank you also to the Happold Foundation, who we're teaming up with tonight. Happold Foundation is a wonderful charity that runs thought leadership events alongside lots of other benevolent activities they do around the engineering world, and they help us record. So this conversation that we're going to have, this panel discussion, will be recorded, and we will be publishing it on the Happold Foundation website, along with far more detailed biographies of the speakers. So if you want to, and hopefully want to follow up with the details of some of the people we're listening to tonight, then that's where you'll find it in about a week's time, and we can let you all know. We're going to follow the Happold Foundation format for City Conversations. So there will be some short presentations, and then we'll open it up to discussion. There are people following us online, and we'll be able to draw in questions from them as well, hopefully. But I think with the presentations I've already seen, we're going to be generating a huge amount of conversation in the room. It's fantastic that we've got a really distinguished panel. And I'm very grateful to John Lyle of Lyle, Bills and Young, who's going to both make a short presentation about some of the work he's done in relation to the topic, and also chair the discussion. So thank you very much, John, for stepping in to do that. John, I think I'm right in saying I might even have met you when you worked for Cedric Price. Is that right? Yes, he's nodding. So John worked for Cedric, and that's I have to say, the distinguished group of people who went through Cedric's office. We're all free-thinking and creative, and it was a fantastic place to have been. But latterly, we probably met 15, 20 years ago when he was doing work on the Olympic Park. He's going to tell us about, related to the pumping of water and sewage. So, John, over to you.
Okay. Thank you very much, Andrew. What I've thought I'd do is, as an architect at the Engineers Club, I feel a bit of an interloper, but I have to say, one of the great joys of my career over the past 20 years is working with civil engineers, so not just structural engineers and services engineers, which I'm normally used to, but working with civils and water engineers. And initially working with the water companies, there was a bit of, well, we always do it like this and whatever. And someone like me would question that. And I would have a wonderful response from the engineers, the civil engineers. Yeah, well, why not? Does that have to be there? And does that have to be whatever? So if I can start with the first slide. Andrew? Anyone there? Oh, there's an arrow on here, is there? Oh, that one. Well, I've got it on there. Oh, it's the next slide. Huh? Oh, it's that one. Right. Yeah. Okay. Right. So, we won a competition to design the pumping station for the Olympics in London. And if I tell you that during the competition, the precedent design by a company called Arabs was a rectangular box made out of blockwork with a tin roof. And when I drilled down into what it was about, below it was a 50-meter diameter caisson, quite deep, another 15 meters deep, divided into a wet well and a dry well, various technical things like that. And so I said to the client once we got the job, well, why don't we make the whole building circular? Then you only have to have one foundation. In other words, the caisson is the foundation. I mean, you know. And he thought I was brilliant because I'd saved them a lot of money, you know. But this is how architects and engineers can work together on clever things like that. So what you're seeing is the Pudding Mill pumping station. As you can see, it's quite close to the stadium. And what you're also seeing is Pinky and Perky, as they were christened by the contractor. Two 20-foot high tanks full of charcoal, huge lumps of charcoal, with the fans at the top, and they would draw the fumes and actually take the smell away. And so I always used to like saying it was a case, finally in my career, of the shit hitting the fan. But we wanted to expose those, and then there was various other things, electrical rooms and whatever, and of course the flue at the top, which I decided to put a light on. And we actually said if there was any fumes and smell, that would change colour. So we had different colours of tubes at the top there, but it never happened. It's always been like that. Anyway, so moving on. And paying homage to Sir Joseph Bazalgette, we went down to Abbey Mills pumping station and found a whole chest full of amazing Victorian engineering drawings and asked for permission to actually borrow them and get them printed on the precast concrete curved panels that we were putting on the building. And so we didn't say this is Joseph Bazalgette, it was just a very slight memory of, because we were right next to the Greenway, which of course had his main sewer going through to Abbey Mills. And it became the first of a series of buildings that we did for the Olympics. Thames Water, after the Olympics, then commissioned us to look at this, which is a treatment works at Crossness, where there is an early Bazalgette pumping station, which is fantastic, and it's still there. And in a sense, what was happening is that Britain, along with Belgium, Holland, and France, this was still the days where we were part of the EU, remember that? Before Brexit, where they sort of said, come on guys, clean up your act. Here across Ness, there was a loading pier, they were loading barges with poo and taking it to the North Sea and dumping it. And so were Belgium, Holland, and France. And it was just not good enough. So Thames Water, bless them, and I'll say that only once, decided to have a plant where they would actually take the poo, which comes from all the sewers congregating from North Kent and West and South London, and bake it into granules. And they made them into the baking process, and then invited farmers to come, and the farmers were queuing up with lorries, and they could take the granules away as fertilizer for their farms, and it was quite a good process. Now, someone might correct me if I'm wrong, but I thought it was wonderful, and this is what the plant is about. In that big shed, it's full of, it's like very large chunks of freeze-dried coffee, but much bigger, and it's sort of put into lorries and then taken over the thing. And there's very little smell after the baking process, and it's it's called a sludge works basically, and we decided to give it a bit of colour and so on and so forth. So And here is the plant that we designed. And also, we started printing some of the engineering drawings this time from Crossness, which was only about 400 yards away, this Victorian building. Now, what I would say, and this is an echoing thing that might be echoed by other people tonight, is that the buildings like Abbey Road, Abbey Mills and Crossness that Bazalgette was part of it, were heroic structures, and he used great architects, and they produced these rather Italian, wonderful buildings, which are still listed and fantastic today. And because the Victorians were showing off their achievement in engineering to actually not only take the sewage out of London, but to actually process it and whatever, and have sewage farms and have these great big pumping stations, and they are spectacular. And they were very proud of it. Then I suppose, in the middle part of the 20th century, one began to notice that sewage works and processing works were not exactly hidden away, but it was, just off the North Circular, hidden away somewhere like that. And, there was no grace or, they were just very ordinary. No one really bothered about the design of them or the appearance of them. And now I think, thank goodness for the Olympics, because they wanted every building on the Olympic site to actually look good and work well and to be eco in terms of its performance and whatever. So, for example, our next project on the Olympics, which was at near Hackney Wick, right at the back of the main stadium. Again, an innovative building, an innovative process where they took a lot of the sewage coming down the main Victorian Greenway sewer at Hackney Wick and converted it and turned it and separated it out into eventually a process where they would go from dark brown to beige to clear water. And that non-potable water is still used, and it was used for irrigating the Olympic Park, which is a fantastic park, as you may know. And so this building did it. And we also designed the Core 10 buildings in the front, which are covering a wellhead, an old Victorian wellhead, which we brought into life again. So, and at this building, as soon as it opened, there were foreign representatives from Africa, Nigeria, from the States and from Canada wanting to see this process. And again, it was, it was fantastic that the Thames Water had actually produced this. Now, I am not aware that they're doing this anywhere else, whereas they should be spinning it out. So we're here this evening to talk about sewage and the ills and problems that we've got as a nation in terms of what's happening to sewage. And I know that there is the technology, and there are the technologists and engineers out there who can do this, and they have done it already. Sorry. So here is inside one of the things, and you could actually go through and see the way they would filter out all the things that they wanted to, all the sludge and the things which was compacted and then sent out and baked into fertilizer again, and the non-potable water was put back into the Olympic Park to irrigate. And of course, everything we did had to be on natural materials, green roofs, and not sedum, but wildlife roofs and things like that. So this was part of the Olympic experience, and we all learned a lot from that. And so I think this is my experience of working in the past few years in the world of water and sewage. Since then, I've been looking at new reservoirs for the Design Council, chairing design review panels about that sort of thing, and also big sewage works outside Cambridge, which is in a big circle, which is right near the A14. And the technology is moving on, and also what we're finding in both in reservoirs and sewage works is that, and I think Julia will touch on this, the public want to know about this sort of thing, and they're fascinated by the technology. And so at this place in Hackney Wick, there is a visitor centre where people can actually see how the water goes from dark brown poo to clear water. And so at these other modern sewage works and water treatment works, there is something where the public can see it, because the Victorians used to show it off, and Bazalgette used to show it off, and so why shouldn't we? Why should we be hiding it? Anyway, that's all I've got to say. Our next speaker is Julia King. And now Julia, she tells me she initially trained as an architect, but she's very much an engagement strategist, very much concentrating on the public issues. And if there's one big public issue, it is water and sewage, our rivers, our seas and our coastal thing. And she is very much on the forefront of really pushing for people to, and the water companies to do something about that. So I'll hand you over to Julia now. Thank you.
Right. Well, if you're an interloper, I am definitely the biggest interloper in the room today, because, yeah, I'm neither a practicing architect or an engineer. But when I when I graduated from architecture school, I actually had the immense privilege, and it was one of my sort of highlights of my professional career. I actually worked for Atelier 10, who I believe I'm one of the supporters for the engineering club. And this was the first project I ever worked on as a young graduate. And I should have actually retrained as an engineer, but I think at the time the thought of going back to university after 5 years of architecture was not something I wanted to do. And cutting quite a long story short, I ended up, because I'm not going to do the whole life story, early midlife crisis that happened in my 20s, but I ended up getting a PhD scholarship, and I grew up in India and decided to do my PhD back in India. So my PhD took me to Delhi. And another long story, and I could very easily do an hour on it. I ended up building a sanitation project. And what's quite interesting about, John, what you were saying, is that the project that we did, it was in a resettlement colony. So at the time, in 2010, India had moved, India was hosting, New Delhi was hosting the Commonwealth Games. They moved over 1 million people from inner city, sort of poor communities, to the outskirts, to what they called resettlement colonies. These resettlement colonies had electricity, but did not have any other kind of infrastructure. And I ended up, over a sort of 4-year period, kind of realizing how important, as an architect, how important sewage was as part of the housing economy, and very naively embarked onto this project to build a piece of sewage infrastructure that was really affordable. And that was my entry point into basically the kind of how weird and wonderful and powerful sewage is. And your story of the sort of the colors of water, effectively, this was what we built, was a septic tank that effectively does that through a sedimentation process. And at the end of it, you had water that could be sort of irrigated for local use, or just put back into the waterways that were actually open sewers. And so it's all kind of, wouldn't meet code in the UK, but in the context of where we're working was a huge, huge, huge improvement. Here's a very grainy picture of me the much younger me, back in 2010 at the Bill and Melinda Gates Foundation fair in Delhi, where I'd made a model explaining this kind of process, sedimentation process, through the kind of projects I was doing at the time, which were all these sort of decentralized, very low cost, very basic sewage interventions. And you can see the little house model there, because it was all about that relationship between a very low-cost, very ad hoc housing economy and the relationship towards an individual's desire for growth, and how that was driven by the addition of a toilet. And so my segue to sanitation was actually these observations that I did more as a sort of sociologist and ethnographer, where I was looking at how people lived in this resettlement colony. And you can see here that this is what having a toilet does to some of the poorest people in the world, is that you go from washing and defecating in a field to, by the next year, they've invested in a toilet. That's that structure at the top. In 2011. And by 2016, this house is actually pretty middle-class standards. You've got huge amounts of privacy, you've got rooms, you've got 2 toilets, and it's beautifully clad in tiles. So, this is this kind of trajectory that I sort of spent my awakening as an architect, that relationship between housing and sewage. And I then, to explain my interloper comment, I then went into academia. So I've spent the last 10 years working largely as an academic at the London School of Economics. And I've done a lot of work around getting young people involved in planning and design. This is me with the mayor of Bogota at the COP summit at the end of last year, talking about how we need to engage with people. And I think this is the arc of all of my work, is that I think there's nothing more disempowering than change happening at you and not with you. And whether that be public space or having effluent dumped into your seas and you feel that you can do absolutely nothing about it. And actually architecture and design and engineering should and can have this really powerful role to play to bring people along with them. And that's the kind of crux of my work, is actually getting people engaged in planning and design. And currently, as a shameless plug, if anyone wants to hire me as an engagement strategist, a lot of our work currently is around getting young people involved in planning and design. And by doing that, by paying them and training them, because I think if you don't do a degree of training, it ends up just being like, do you prefer A or B? Which is a really disempowering conversation to have. But with the plug over, I've skimmed through. Why I'm here today and why I got invited was that I'd done a piece of one of my last projects that I did at the LSE was a kind of a think piece around sewage infrastructure in the context of where I now live on the North Kent coast. And it was actually exhibited at the Design Museum, and I'm sorry it's no longer showing because it was the year finished this August. But it was effectively a series of films and a drawing, which you can get in touch with me and I can share the films with you. Why we did that work, well, why I did that work was that all of a sudden I realized that this thing that I had been doing in India for all these years was painfully relevant to my literal doorstep. We're now in a situation where you have sort of huge amounts of sewage, just raw sewage being discharged into rivers and waterways. In 2023, raw sewage was discharged at an average of 1,000 times a day. So we're having more discharges and the volume is more. So you might say to those who know what a conventional sewage system should do, yes, discharges are normal, not at the volume, at the amount that we've had recently. And so this is, I sea swim and how I can check as to whether I am swimming in shit or not is I have to go to a website by a company called Surfers Against Sewage, which is the middle image. I did not go swimming today because where I live is where that big red X is. And I also pulled up the Rivers Trust, which is an organization I think is really amazing and do amazing work. And why I'm showing you this is that actually the forefront of the argument against the sewer companies are actually local people. These are people who use the river, just people who like swimming or who care about our environment, who are shouting about this the loudest. And how they're doing that is using tools and data to try and make the case. It's interesting with the Surfers Against Sewage is that sometimes now there's a backlog because the water companies don't really have an obligation to publish this stuff. So all gets quite sort of murky in many ways to understand what the situation is today. But really, the problem isn't so much just discharging, because I'm not surprised it's been absolutely pouring with rain. Is it a surprise that there's sewage has been overflowed into the rivers today? Maybe not. However, this is an image from August of 2023. It was a really hot, sunny day. It hadn't rained for weeks, yet I couldn't swim that day, and it was full of poo. Why is that happening? And that's almost the real problem, and it's a very distasteful term called dry discharging, when sewage companies are just letting it go. It's not because there's a rain overflow, it's just because I don't know why, but we can guess, but they're just doing it. And again, it's activists on the ground who are trying to highlight, because this is actually illegal, and so it's activists who are highlighting this problem and trying to put the water companies to account, which is a very difficult thing to do. So going back to sort of my think piece that was at the Design Museum, it was really this idea and a call to sort of say, actually, and I think, John, exactly how you introduced, we don't have to be in this situation. We have all the tools and the engineers and the ideas ready at hand. And that was a bit of the piece, was to sort of say, look, we could do these things. And so I designed a series of interventions along the Kent coast. Sort of one was using oysters, as sort of an idea of a natural system. I'm going to go to this slide. I sort of came up with 4 different ways that you could treat our sewage outside of a kind of conventional system. One was this idea of like a living system, sort of like using animals, or natural systems, and we're going to hear a lot about that today from George, about reeds. We have mechanized systems. So whilst I was at the LSE, I did a lot of research looking at sewage infrastructure in Ethiopia, where social housing has actually outpaced infrastructure. And you've got this huge ecosystem of bioreactors that actually treat waste very locally. It has its problems, it requires a lot of electricity, but anyway. And then parallel systems, sort of like sponges, which I think, Rhys, you're going to talk about. But the point here, and it's really inspired by Bazalgette, was that actually we need to think of infrastructure as a public good. And when we do that, these investments can do so much more than just treat the system or the thing. And it can be part of a kind of, I was talking to the other panelists, I really want an infrastructure renaissance, which was kind of what Bazalgette did. He didn't just build sewers, he built the embankment, ferries, bridges, 40,000 slum dwellers were rehoused, public footpaths that are still to the public today. It was an amazing public vision for what infrastructure can do. And he also knew that he needed to think about the kind of institution that could drive that project through, which is the London Metropolitan Board of Works, which became the LCC, which is our current system of governance. So we have so much to thank Bazalgette for, not just the fact that you can shit in a toilet. And that's what I think we need now. We need this kind of pressure. And it needs to be around public good when so much of our public life is being eroded. And so that was what these provocations, these pieces that I put together for the Design Museum, was taking projects from around the world and collaging them into my life and where I live. So this was imagining in Swale Cliff. I was imagining it's currently an unmanaged wetland. And I was like saying, wow, we can make it into a managed wetland and have a tidal pool where you can go swimming. How wonderful would that be? Or, this was sort of really, I love these projects in the United States where they're sort of restoring oyster environments. And this was just to go back to the Swale Cliff project, because I'm absolutely raging about this. So this was the proposal that I put together, really stealing from a lot of the ideas of what we've done in India. And it's really painfully simple, and I think we're going to see more about this. It's just sort of putting the sewage through reeds and sedimentation processes, and in effect, but then having this sort of vision of the swimming pool. But what has actually happened in the interim is that Southern Water have done what they call an engineering project, and you can go online, and I do encourage you to go see this video, this sanitizing video. They've actually just taken the pipe and built it further out to sea. A £19 million project, when every day we hear about a cost of living crisis. They've spent 19 million to extend a pipe further out to sea, and in a glorious form of gaslighting, we live in a tidal area. It makes no difference. So, I find it absolutely shocking. I managed to get onto a helicopter, don't ask me how, and this is my photograph of the pipe. And I also just wanted to highlight the text of the further gaslighting, where it says here, outfall, this will mean any stormwater releases from this outfall, which only happen rarely as a last resort, blah, blah, blah. Rarely, so going back to the work that Surfers Against Sewage do, these are the Swale Cliff releases recently. They released on the 30th of September, 27th, 26th, 25th, 23rd, and so on. I would really like to have a conversation with Southern Water and ask them, define rarely. So, as my last slide, I just wanted to show this image. I took it on Saturday when it was gloriously sunny. If you travel around sort of where I live, between Canterbury and Whitstable, you will see these signs everywhere. There's so much house building that's happening. And I am a huge believer in people having dignified homes. I am not a NIMBY or anything like that. Yes, let's build more homes. But what's happening in places like Whitstable and Canterbury is that homes are getting pitted against sewage. I don't know if you can see in the image, that bottom one there says no more homes, no more sewage. And it's because we have a serious problem around obliging companies to, where it does feel like this, that if you build more homes, you're just going to have more sewage coming into our seas, because that is actually what's going to happen. And this becomes a huge problem. And I think it's a huge problem at the heart of our communities that needs to be fixed. And I think we, as design professionals, should have something to do about that and say about it. So that's my rant over. Thank you very much.
Thank you, Julia. That was excellent. We're going to do a chat Q&A at the end of the session, but I next want to call up Rhys Williams. Basically, he is famous for nature-based drainage solutions and SUDs, which some of us know a little bit about, but this guy, he's an expert, and so he's well worth listening to. So I'm looking forward to it. Rhys.
Thank you. I'd also like to say that I also coined the phrase sexy drainage as well as part of my rhetoric. And hopefully we'll be talking about some drainage, whether it's sexy or not, I'll let you decide. But when preparing for this presentation, I was reviewing sponge cities all across the world, and I came across this quote from nearly 250 years ago from Philadelphia's favourite son, Benjamin Franklin. And what he said was, covering a ground plot with buildings and pavements which carry off most of the rain and prevent it soaking into the earth and renewing and purifying the springs, the water of the wells must gradually grow worse and in time be unfit for use, as I find has happened in all old cities. Now you change a few words in that with water to the wells, to rivers and seas, the Thames, and you change old cities with London and replace it with any of the towns and cities we've got in the UK. And somehow 250 years later, we've still got the same issue. Now, Bazalgette, we've been talking about it a lot, and it's brilliant as a civil engineer. Normally, everything goes to the structural engineers, but what we need to do is learn from the past and what we've done before. And as we said, the Great Stink, Thames sewer pollution, is not something that's a first. You know, we first encountered this 200 years ago, and we got Mr. Bazalgette involved, who took ideas from Europe, from the likes of France, to take water, to take sewage and to pipe it, and to solve the issue of waterborne diseases, open sewage in the streets, and move it away and take it out to East London. And now what we've got in terms of present issues is urbanisation. Now this is a bit of a GCSE diagram and something most drainage engineers have probably got tattooed on their backs of their eyelids. So what we've got on the right, on the left-hand picture, as you can see there, is pre-urbanisation, when we've got green land acting as a sponge, and what you've got is a time hydrograph at the bottom there, which shows when we first get that downpour, we see initial slight peaking as the water hits, some of it's taken up and it slowly runs off down to the river. Now what happens with urbanisation is the water hits the ground and we suddenly get a massive spike in discharge that runs down through our system and straight out into the sewers. With that, what we've also got, this is multiplied by use of typically combined systems. This is where we have sewage and surface water entering the system. On a normal running day, what should happen? The sewage is flushed down the toilet, it then drops out and then is taken off to the treatment plant. What happens when we get a sudden downpour is that the sewers overflow and they have to have an emergency discharge into the sewer overflow, whereas Julia says not so rarely happening. Combine that with also some of the sewers that Bazalgette originally put in still being in use today, We have quite an antiquated system which has seen little upgrade since the 1800s. Factor in something Bazalgette probably never thought of, climate change. Year on year, we're seeing increased rainfall, we're seeing hotter summers, and we're also seeing that peak rainfall increase as well. So our drainage system's having to cope with more, as well as the urbanisation. So what we're doing is stacking problems on problems on problems. So what's our answer to these issues? Well, we set up a company called Bazalgette Tunnel Limited, and we build a 25-kilometre sewer under the Thames, 7.2 metre diameter, costing the people and the taxpayer £5 billion and is yet to come into use. So what you're telling me is in the 250 years since Bazalgette was first here, what we've done is create the combustion engine, go through an industrial revolution, put people on the moon, send people to space, and suddenly we've gone, I know what, Bazalgette had the right idea. Let's put in a massive pipe and take all our sewage somewhere else. So, what do we think is the answer? Well, our marketing team came up with this great graphic, which I've certainly had to put in here. And what we need to do is take the urbanisation and the landscape and bring it together in a synergy to create a sponge city, in effect, where we get the best of both worlds. We're able to live alongside nature. So I hear you ask, how do we actually do that? So we've been working very closely with Lambeth, and I've used some of their slides. Matt Panow, who's their Climate Change Adaptation Manager, to give it the full title, has been working tirelessly on this, and we've worked with a number of projects with them. And you can see the Borough of Lambeth highlighted in green here. And what they've done, they've used GIS data to have a look and see what kind of surfaces they've got in the borough. So on average, 30% are vegetated, parks, grassland, private gardens. Around 30% are roofs and 30% are pavement. And what they've done then is split it down into what's private, so people's back gardens, people's roofs, can't do a lot about that. What's local authority? Highways, footpaths, those types of things. That the local borough and the local council have the ability to do something and to change something. So, going back and reviewing the question is, what is the source of all this water? What we've done is put a giant pipe at the end of the water, but where is this water coming from? So using GIS data to map the topography and to map the flow paths which run through our boroughs, what they've been able to do is to essentially trace overland rivers running through the borough and where they go when eventually, by topography, they get down to the Thames at the lower end. Then they've stacked on additional parts, so where people have got driveways, secondary highways, to build up this model about where's most effective to capture water at its source and on its way before it enters the system. So going back to that combined system, what happens if we take all that water out and we just let it do its thing it was designed for, with just the foul water and effluent in there? So how do you pick the target? So what happens here was looking at the roads which essentially act like rivers to convey where the most water's flowing, where it'd be able to pick that up. So looking at things like A roads, B roads, secondary roads, footpaths, and creating a hierarchy of regional control, site control, and source control. So essentially taking it from the macro and distilling it down to the medium before then you get to the micro level. Taking individual case studies of where you can fit on-street suds features, so rain gardens, swales, these miniature sponges, and then how do we start quantifying the benefits? At the end of the day, cash is king, so how do we show people what we're going to build is going to be effective? And what we're able to do is to take the cost of implementing on-street rain gardens and then offset that against the cost of the cost of cleaning up after a flood. So houses, insurance, all these other things to factor in how much it costs to build and what that flood protection is worth. And we've taken this from the micro and spread it all across the macro of the Borough of Lambeth. and given each one of these features a BCR, a rating of offsetting the build cost to the worth cost. And the broad brush high level piece is to apply a nature-based solutions across the borough to soak up all these individual runoffs would cost in the region of around 1.2 billion. So to put that in context, that's around a quarter of the cost of Thames Tideway. And that's just on water quantity alone. That's before we've got to all the other SUDS benefits which come with it, including the water quality, so taking any hydrocarbons, any pollutants out of there, biodiversity net gain, increasing the amount that we've got across there, across the borough, amenity, providing on-street greenery, urban heat island effects and reducing that, and really bringing these urban and landscapes into a synergy where we're able to solve flooding issues. So what is the answer then? Do we go for these big infrastructure pieces that we see the likes of Thames Tideway, or is there an option to do a scattered nature-based solution across each of these boroughs and create ourselves a real sponge city? Thank you for your time.
Thanks very much, Rhys. That was brilliant and a real education, but more afterwards, a bit of Q&A. And our fourth speaker is George Rose. Now, George is an engineer who's very much involved in constructive wetland design, so similar sort of territory, but a different view on it and a lot of experience. So, George, could you come up and give us your piece?
Thanks, John. So yeah, I'm George Rose, Director of Water Design Engineers. I'm a civil and environmental engineer. I'm not an ecologist, but ecology does play a big role in what we do with constructed wetlands. So we're only a very, very small consultancy. There's less than 10 of us, and we've got offices in High Wycombe and in West Sussex, where I'm from. Yes, we're wetland designers. It's a bit of a speciality of ours, constructed wetlands. We're members of the Constructed Wetlands Association, CWA. We're actually now accredited members of the CWA, and we're only one of 3 companies that are. This graphic's not as fancy as Rhys's, but it sort of shows what we do. I don't expect you to read that, but we do sustainable drainage systems, but not as much as Rhys is doing. It's a bit of a new area for us, sort of on the back of wetlands, and wetlands do play a role in SUDS. Constructed wetlands and wastewater, there's an overlap with industrial wastewater as well. We've got applications where we've designed constructed wetlands to manage industrial wastewater on site. So I'm going to give you a sort of a whistle-stop through the various types of constructed wetlands. So this is the free water surface wetland, which closely mimics natural wetlands. Essentially, we've got a permanent body of water, which is typically anything from 100 to 300 mil deep. And then we have emergent plants, which could be reeds, or it could be bulrushes, anything that likes getting its feet wet, basically. And then, of course, the soil. The soil is an all-important aspect, and the root network, the rhizomes of the plants, they're all integral to making a free water surface wetland. Then we have vertical flow, or vertical subsurface flow, VSSF. These are typically very small, and you'll see them in sort of off-grid situations where somebody might have a septic tank in a rural area with 1 or 2 houses feeding into it, and the water coming out of the septic tank's not quite clean enough to go to a ditch or a stream, but a vertical flow wetland can help polish that up and make the quality good enough for that application. So essentially the water comes in and is discharged over the surface of the bed, and it's not so much soil, it's more of a granular gravel or sand media. The water is sort of inundated in doses, and then it spreads out, and then it percolates through the sand, and then it's picked up through an underdrain at the bottom, and then taken away. And then we have horizontal subsurface flow wetlands. which are very similar. They're also very small in scale. You'll find these on the back end of sewage work. So again, very, very small, usually sort of square in shape, similar to the vertical flow, but instead of discharging the water over the surface, it comes through one end, sort of soaks through one end, and then percolates horizontally through the media in contact with the reed, the reed roots before it comes out at the back end. And then you've got like a small level control device at the end, so you can adjust that water level. So how and where can wetlands work? There's more and more applications for them today. I don't know how many of you know about nutrient neutrality. It's hitting certain areas of the country. Well, in England, it's an issue sort of policed by Natural England, who look after the habitats regs. It did catch a lot of people unaware, but that's where we've really come into our own with the wetland design. It's been probably the biggest driver for wetlands in our experience over the last 3 years. So wetlands need to be fed. They need a source of water. That can be abstracted flows from rivers and streams if there's particular contaminants there that we want to get rid of, especially nutrients. Final effluent from sewage works, I've already mentioned that. So we have small reed beds on the back of sewage works that are trying to reach ever more stringent permit levels with respect to their environmental permits. So they're good for polishing nitrogen and phosphorus down to lower levels, certainly nitrogen on the smaller scale. And also, you know, we've seen Reece talk about SUDs, so surface runoff from urban and agricultural landscapes. Wetlands are very good at sort of mopping up sediments. A lot of phosphorus is tied up with sediment and soil erosion, so there's a lot of low-hanging fruits with wetlands and agricultural drainage. Where can they be located? Obviously, water wants to find its way downhill, so sort of flat, low-lying ground is ideal. Although having said that, I've got some constructed wetlands that are actually on a slope, almost like a sort of terraced paddy field, because if you fudge the rules a little bit and you bring pumps into play, you can start to do other things. I'll talk about that a bit later. We size our wetlands. People say, well, how big does a wetland need to be? Well, how long's a piece of string? It all depends on what the flow rate is that you're handling, what the contaminants are, what the concentrations are of those contaminants, and then what are the target concentrations of those contaminants? How much are you trying to bring those contaminants down? So we use a model called the PKC model, which is the most robust wetland design model in the industry. And then that's used either to sort of work out from an area how much you can achieve in terms of water quality, or for a given water quality, how much area you need. There's two ways of looking at it. As I mentioned, pumping stations can be used to transfer. If you've got a great source of contaminated water, but gravity won't allow you to do anything nearby because you're already at the lowest point, you can have a pumping station and then deliver that to somewhere nearby where you've got some suitable land. And of course, wherever you do build it, it must be accessible for construction and maintenance, which is a big issue for wetlands that sometimes gets overlooked. So yeah, what are the benefits of constructed wetlands? And again, there's some overlap here with what Reece has been talking about. Biodiversity net gain. So going back to the free-water surface wetland, which most closely mimics natural wetlands, they are a fantastic opportunity for biodiversity. I'll talk about our example later, but reed beds have been in decline over the last 150 years with draining of land for agriculture. So in a lot of cases, we're putting back what was there originally in some of these low-lying riparian landscapes. Carbon sequestration, we've done a literature review. We don't have enough evidence to sort of design a wetland to mop up a certain amount of carbon because there's not enough information out there, but there's enough information for us to know that a well-designed wetland, a free-water surface wetland, as long as it doesn't have too much open water, will sequester carbon. So yes, you do get greenhouse gas emissions from wetlands when you get the natural cycle of the leaf litter from the reeds coming down after the end of each season and then rotting into the soil. That does give off, you get CO2 and you do get a bit of methane, but the carbon that gets pulled in by the growing of the plants and the breakdown of the contaminants coming in outweighs that, so you do get a net benefit in carbon sequestration. Natural flood management at NFM, wetlands can do lots of things. They can improve water quality, but they can also act a bit like a sponge and soak up huge amounts of storm water and let it out slowly. Public access. People like wetlands. They look nice when they're designed nicely. They can be integrated with boardwalks and pond dipping platforms. And certainly going back to the SUD sort of landscape, it can actually increase the value of properties that look out and have access to these kind of places. They can be more economical than grey solutions. I won't say they always are, because it depends on what's happening. It depends what you're trying to achieve. Sometimes a little bit of grey can help the wetland, and sometimes the wetland can help the grey infrastructure. Treatment of nutrients, that's a bit of a forte for constructed wetlands, certainly the free water surface wetlands that we design. Certainly with the nutrient neutrality, nitrogen and phosphorus is the main target for what the application is. And there's also literature that shows studies for microplastics, pharmaceuticals and forever chemicals. They all come down consistently in constructed wetlands. And again, there's still not enough information for us to use a robust design, but we know that there's a net benefit. So, and they can work with grey solutions to improve operational efficiency. So I think somebody was mentioning a membrane bioreactor earlier. I think it was, yes. And we know that wetlands do a lot of heavy lifting in terms of organic removal. So membrane systems typically get fouled. They undergo biofouling. Then they need chemicals to clean them. Those cleaning cycles can be reduced if you've got a wetland as part of your solution. So they work nicely with other technologies. So I'm going to talk a little bit about a specific case study that we worked on. This is a free water surface wetland near Ashford, a place called Conningbrook. And again, it was for nutrient neutrality. So this was a private scheme. It was the first of its kind, as far as we know, in terms of mopping up nutrients from the catchment to allow housing to be built. We abstracted, or are abstracting water from the Great Stour. We're just north even of Ashford, so we're downstream of the sewage works and a number of agricultural drains and sewer overflow points as well, which we saw mapped on the Rivers Trust map. I was actually quite amazed to see how many there were. So we've got a real cocktail of horrible stuff coming into this, which is supposed to be a pristine chalk stream. And we hear a lot about chalk streams, but if you looked at this particular one, you wouldn't think it was pristine in any way. After each time that there's a heavy storm, you see a tide mark along the riverbank of bottles and cans and plastics to see the high tide where everything that's sort of been flushed out of Ashford. Yeah, so it's not. It can be nice when the rain's not. Well, it's not raining. But anyway, so we're extracting water from the river at a flow rate of 20 to 110 cubic meters per hour. What does that mean? Well, it's actually a very, very low percentage of the flow in the river. For anybody that doesn't know what the Q95 is, it's the flow of a water body or a stream or river which has exceeded 95% of the time. So it's usually used as like a low marker. So it's one of the low flows, and of that we're only taking out 1.5 to nearly 6%. So tiny in terms of the impact on removing water from the river. But even with that tiny flow, from a design point of view, using our model that I talked about, we can remove 48.8 kilos of phosphorus and just under 4,000 kilos of nitrogen per year from the catchment. And that enables 750 new homes, which are just on the other side of the river. And our client was Quinn Estates and Red Row Homes, I should mention. So this is the sites that we were given. I say given because when you're finding land to put a wetland on, you do have to consider a few things. So this particular area, you can see it's a sort of like a pastoral landscape. The landowner hadn't done anything with it because it's underwater for part of the year because it's in flood zone 3. But with wetlands like being wet because the clue's in the name. And being in flood zone 3 isn't a problem, despite what some might think. It does create some issues, but as long as those issues are dealt with and mitigated in the design, it's all good. So our wetland design for this free water surface wetland consisted of 6 cells arranged in 2 parallel pathways. You can see that, well, it's very, very small print on the drawing, but that gives an idea of the layout. And then the next slide, you can see the flow path. So the river runs this way. You can't see the cursor, can you? From top to bottom, sorry, bottom to top. Same direction as the arrows. So we like our wetlands to flow in the same way that the river does. The orange arrow at the bottom is where we have our pumping station. We're actually pulling water out. The reason for needing a pumping station, I should have mentioned, was because wetlands require a lot of earthworks. If we wanted gravity to do the work for us, we would have to dig down so deep that the spoil we would generate would just make the project not worthwhile. It would be way too expensive and we'd be digging right down into the groundwater. So we had to sit them at a certain elevation, which was high enough to not generate too much spoil, but low enough not to make the flood risk in that area any worse. So within each cell, we have what we call spreader channels. So we have a pipe coming in, and then it's distributed out through these spreader channels because we're trying to spread the water out through the cell. We want what we call sheet flow going out through these cells, maximising the contact time between the water that's contaminated, the reed stems, and the soil. So the reed stems and the soil is where all the magic happens. It's where all the microbiology lives. The plants themselves, their active root network, the rhizomes, they do take nutrients out of the soil. But then we have these microfilms that build up on the reed stems, which are even there after the plant's dormant at the end of the growing season. So they provide vital substrate for all that microbiology to live on and then interact with the water. So we have various processes happening within these cells. We have sedimentation, phytoextraction, the plants actively taking nutrients out of the soil that comes from the water. And then we have nitrifying bacteria and denitrifying bacteria. So the nitrogen that comes in the dirty water eventually ends up, after several stages, it goes to nitrogen gas, which goes to the atmosphere, which is harmless. Phosphorus is a bit different. It doesn't end up as a gas. It gets tied up in the plant tissue, but most of it gets tied up in sediment that comes in, and also new soil, because new soils are being made all the time in wetlands, which creates new sites for the phosphorus to adsorb to. So eventually, and when I say eventually, I'm talking about after a couple of decades, there might be an over-contamination of phosphorus that's bound up in the soil, in which case then it's time to excavate some of that soil and put some new soil back, but that's quite far in the future. This is a close-up of what happens between the cells. So these shapes here, these are the spreader channels that were shaped, coloured blue on the previous slide. And then we have submerged head walls set into those spreader channels, which you can't actually see when you're actually at the wetland. Then there's pipes that connect through to what we call weir wall chambers, which is a chamber with a weir wall inside it, which also has a penstock that controls the water level in the cell upstream. And we can control the water level anything down to bed level, i.e. empty bed, if we need to maintain the wetland cell, or all the way up for a maximum water depth of 300 mil. And then you can see that this is a section through that, through a spreader channel and the weir wall chamber. So we have a penstock set into the weir wall in the middle, which we can adjust. You can also see there's like a pink outline here. Can anybody see that? It's these cells did have to be lined, and it wasn't cheap. So the liner we used was a geosynthetic clay liner, GCL. The reason we had to do that was the soil that we found on site, even though it was probably too impermeable by SUD standards, because you deliberately want the water to drain away. But in wetland design, it's the opposite. We want to retain the water column, because if you haven't got the water, it's not a wetland anymore. And we don't want a large, expensive soak away. It would have been a bit of a white elephant. So I don't expect you to see the small print here, but this is what we call the wetland water budget. So we know we have a flow that's coming into the wetland that we've designed, and we're going to treat it. But what comes out the other end isn't what we put in, because we're going to get losses through infiltration. We're also going to get losses through evapotranspiration, which varies according to the season. And of course, we're going to get rainfall, which has an input. So the water budget looks at all those inputs and outputs over the season, and then we're just making sure that there's still a positive flow at the end for each season. We don't want any minus figures, because then we know that we're losing our water column and we could be in trouble. So for that particular wetland, there was a number of issues and obstacles. But like I say, it was the first of its kind, so we were hit with quite a few objections from various people and bodies. Spoil disposal was a massive issue. We were lucky in that everything that we took out of the flood zone to excavate for the wetland cells was able to go into an adjacent field and be spread around. If it had to been taken away as muck away, it probably would have bankrupted the project. It probably wouldn't have happened. So that was fortunate, and we always recommend that spoil is dealt with locally on any wetland project, mainly for that reason. Flood zone 3, I mentioned, where we built up our berms that surround the wetland cells to keep the water in. They impacted slightly on the floodplain. So when we're looking at floodplains in flood zone 3, around rivers, so especially main rivers like this one, we're not allowed to reduce the volume of the space that the water can take up during a flood. So we had to analyse how much of that space was taken up by the berms, and then we had to do some compensation on the land just south of the wetland to make sure that the water still had some space. It's all a bit complicated because it has to be level for level in the compensation. It's not just, oh, we need so many cubic metres, I'll just stick it over there. It has to be exactly the same level. So that was a little bit tricky. The abstraction licence was interesting. That took 11 months, lots of negotiations with the Environment Agency. The Environment Agency were interesting because we had to deal with lots of little bodies within the Environment Agency who each had their own little concerns. There was one chap who was all about geomorphology, so that's the natural shape of the river and how it wants to keep moving in years to come. We have learned a lot of lessons on this project. The wetland cells were too close to the riverbank. We know that now, and he kind of pointed that out. But we had to come up with some mitigation. I won't go into too much, but we had to do a water framework directive assessment, because the point at which we take the water out and the point we put it back in, they were half a kilometre apart. And even though I explained earlier that it was a tiny percentage of the flow, they were so risk averse at the Environment Agency, they said, no, you have to do some mitigation, even if you prove that the effect is negligible on the river. So we had to do some in-channel works, basically narrowing the channel in some areas using revetments or woody debris. We're going into the realms of river restoration now, but it's a sort of an offshoot of what we do. But essentially, it's making sure that the river, in the summer at low flows, the channel is narrow enough so that there's still enough depth for wildlife. It makes sense in theory, but I think what we really tried to prove to them conservatively, that there wasn't going to be any impact on the level. But anyway, I think there might have been a hidden agenda there. I might be talking out of turn, but they probably had some ideas for the river that they wanted to implement, and saw us as maybe a bit of a vehicle to do that. We also had a lot of local objections, and I think that was just because nobody had ever seen anything like what we were proposing before. even though this wetland technology we're talking about is nothing new, it's been around in various parts of the world for many years, which is why we have so much data available to make our designs, especially on the nutrient mitigation. But nevertheless, we did have the local objections, but we dealt with them one by one. We had a meeting with the local parish council, and I think they were happy in the end that we knew enough to make sure that we weren't going to cause a massive flooding issue. Prevention of pollution during construction was also another issue. It's interesting that when we started this project, the very day that the contractor set up, I noticed there was something of an oil slick present in the river. So I panicked and thought, I better report this, because otherwise people are going to see construction firm turns up on site, suddenly there's oil in the river, and they put 2 and 2 together and get 5. It certainly wasn't us. I made sure of that for a start. But I got onto the Environment Agency, reported it, and then never heard anything back. But I think it just sort of highlighted how polluted this stretch of the river is, and how what we're doing, even though we're only just trying to enable some housing, there are other benefits to what we're doing too. So this is the wetland when it was under construction. All the white you see there is the GCL, the geosynthetic liner, which has a backfill of 300 mil of soil, which is all site 1. And then in that 300 mil of soil, the reeds are planted. So I could have shown you loads of construction slides, but I know we're tight for time. This is an aerial view. So at the bottom, you can see a little footbridge with a building next to it, just about. That is our pump house, and it's got a green roof. And it also had to be raised up above the 1 in 100 year flood level, so it's quite high up, which you can't see from this angle. So this was pretty much at the end of construction. We already had some water available to pump around the cells, because we had to plant 144,000 reeds at density of 4 plants per square metre. And because this was in the summer, I know we had a bit of a wet summer last year, but we still had to make sure that those reeds wouldn't dry out. So we had lots of water being pumped between the cells immediately after planting. And you can see how close the cells are to the river, which is on the left-hand side. So we finished construction at the end of October, well, this time last year actually. We had a bit of a crazy winter, a lot of flooding, and we had some repairs to do at the beginning of this year. But the wetland in earnest started actively treating water from the river officially on the 13th of June, which is when we actually started monitoring in terms of water quality. So to date, and this is based on the water quality results that go to an accredited third-party laboratory, on average, we're taking out 3,765 kilos of nitrogen per year at an efficiency of 63%, which is pretty good. It's slightly lower than the design, but we're only partway into the year, so we need to look at a full 12 months. But on phosphorus, we're doing great, over 50 kilos, which is more than the design, at 84% treatment efficiency. So I can't be upset about that at all. And this is what it looks like close up now. And these photos were taken in the last couple of weeks. So I say we had some damage over the winter. The berms that surround the cells were left low in a couple of areas. So when the river came up and flooded, like it always does every year, it had 2 funneling points, and the water came in a torrent in 2 places and swept away a lot of the reeds that had been planted. So we've got some big bald spots. I've got enough of those. But the really interesting thing with the river flooding, it was a bit of a mixed blessing, because whilst the force of the water took away what we planted, the sediment within the river water is so full of all the seed material that's within the river channel, it deposited bulrush seeds, basically. So what we're looking at in the photo on the left, there's a mixture of the reeds that we planted, but most of it that you can see in that photo is Typha latifolia bulrush, which just shot up everywhere. I was amazed, but then I suppose I shouldn't be amazed, because nature is pretty incredible. And then this photo here sort of shows a couple of things, really. So the photo on the left, I don't know if you can see in the distance, there's a lot of geese. This wetland is absolutely teeming with life. And I'm surprised at how much there is in there. I mean, I didn't think we'd have fish, but the photo on the right, you can't really see it, but this is the final outfall before the treated water goes in to the river again. And there's just fish everywhere. And I was taken aback because we didn't design it for fish. There was a question that came up during the planning process from an ecologist saying, is this going to benefit fish? And I said, well, maybe. I said, we don't know until we build it. I said, there's no reason for it not to benefit fish because we know that with the wetland birds like herons, when they're wading, fish spawn sort of sticks to the legs and then they go into another pond, and that's why you get fish appearing out of nowhere that, oh, I didn't put fish there. No, nature puts the fish there itself. So I was there with my partner the other day, and we just couldn't believe the number of fish in the cells and in the outfall, and no dead fish. It's not like they're growing and then, oh, I can't escape, and then dying. It's almost like a fish farm populating the river. So that's just a happy coincidence because it wasn't by design. We knew there'd be a benefit for biodiversity, but I'm absolutely amazed. There's frogs everywhere. When you walk around the perimeter of the cells, you just see these things flying everywhere. It's just frogs jumping out in front of you. There's herons, kingfishers, egrets. I'm a bit of a bird spotter, so I'm quite happy with that. But yeah, so it's like a double-edged sword on this photo on the left. It shows there's supposed to be plants there. It's not supposed to be open water. That's where we had a lot of losses. So we will have to do some active replanting next year. I know we're tight for time, but there was just one other project I wanted to just touch on because that was nutrient neutrality, but the theme is sewage. We work on wetlands for different applications. Sorry about all the words and no pictures, but we've done a project recently for a water company that's already been mentioned tonight, and specifically looking at how a wetland might be able to help with sewage spills. So this is a tiny little rural sewage works in West Sussex. It has a dry weather flow, sorry, there's a bit missing there, dry weather flow of about 60 cubic metres per day. And from the Rivers Trust website, I could see that in last year, the storm overflow from this work spilled 127 times for nearly 2,000 hours. So that's not acceptable. We're all fed up with it. So I was keen to get involved in this. We looked at several fields adjacent to the works where a constructed wetland could be created. And we ran all the numbers, all the modelling. We looked at various different flow scenarios. And we actually found that a 1.14 hectare freewater surface wetland on the neighbouring field could replace the bulk of the works and handle all of the sewage spills, helping them to comply with the existing permit. So the water company were really happy with this, and even their ops team were happy with this because the alternative would be shutting down the sewage treatment works and then having it all pumped to a neighbouring town which is 8 kilometres away at great cost, and you're just kicking the can down the road. The text in red is the negative stuff. So this is only what I found out last week. So DEFRA's latest guidance on nature-based solutions, and this is their guidance for the water companies, is they're making the water companies jump through far too many hoops before they're saying, yes, now you can look at a wetland for that application. So for this small treatment works, they're saying, well, you need to go and reline all the sewers because then that prevents too much infiltration, which might be driving the spills. Well, then that can cost anywhere from 5 to 10 million, depending on the network. The cost of this wetland, based on the one I've just shown you, it would probably be just over £1 million. So probably about a tenth of the cost of the alternative. But I really felt for the chap that I'm working for at the water company because he had his head in his hands and he said, my remit is to get wetlands into our company's projects, and I've just had my hands tied. So we're doing everything we can now with this feasibility study to really try and convince the powers that be that they should just let us get on with it, because it's a win-win for everyone. and I dare say it might even get some leakage to some outlets, and potentially a Mr. Sharkey might find out about it, and then we'll see what happens. But anyway, thank you so much for listening. That's me.
George, thank you very much. That was brilliant. And one point, I felt I was back at school with a chemistry lesson, but it's but you didn't blind us with science. It was fantastic. So yes, so now we're going to a session where please ask us any questions, and the appropriate people will pile in with stuff. But I think we've all had an amazing fill of information this evening, and so over to you. Any comments, critiques, suggestions, etc.? Gentleman over there.
Hello, my name's Charlie Hicks. I'm a councillor in Oxfordshire County Council.
Oh, hi Charlie.
I saw this on Julia's LinkedIn, so thank you for sharing it. And working with her before. We sort of two-part question really. One is in an area that I'm representing, it suffers from sewage overflows, and I'd be interested in any examples you've heard of Thames Water basically funding sites or other or wetlands that can help, where local authorities can work with water operators to deliver some of these solutions. And secondly, they've just announced, I think, £240 million to upgrade the sewage treatment works south of Oxford. And I'm interested in your perspective, based on all the different options here, how likely are they to be looking at some of the things that we've been talking about today to get these nature-based solutions in, or where are the kind of policy levers that you can pull to kind of encourage some of what you talked about today to make it actually happen?
It's very interesting. I mean, George, you were a bit gloomy about people like DEFRA and the powers that be, but
Yeah.
why are they like that?
I think everybody says, oh yeah, nature-based solutions are the way forward, and you see the banners and the headlines, but when you drill down into the detail and the regulatory detail, they are very, very overcautious, and they like to cling to their sort of grey solutions, and they see nature-based solutions as the last resort. That's how it comes about. We see it personally as an easy win, low-hanging fruit. Get your wetland in, and yes, it does work well with grey. You do need grey infrastructure. I mean, you've seen the slides. I've got concrete in my wetlands. Grey is unavoidable, but I think they're missing the bigger picture, and I think it's just because there aren't enough examples and case studies on soil here in this country where they can be comfortable and say, oh yeah, it's like that one. Yeah, we will have one of those, please. So I think they need to take a leap of faith.
What about overseas?
Oh, well, if you go to the States, I mean, the wetland designs that we work to, from a company called Cadlick and Wallace that made the Bible for wetland design, it's about that thick. They've got numbers of case studies throughout the States in different climates as well. So we've got such huge amounts of data to draw from. We've got the ability, but I think it's just the regulator needs to have some faith.
Yeah.
So, John, I've got a question online which just follows that up, which is, what do the panel think about the Hammarby Stockholm example and their water cycle model? Even the heat from the sewage is used and the residue used to grow trees. In that case, a new settlement transformed a rundown area is now a smart place to live. So I don't know whether...
Yeah, has anyone been? I've been to Hammarby. It's fantastic, and it's wonderful, beautiful, newish housing. But it was developed some years ago, but it's all based around water, and they make everything work. So I don't know whether any of the rest of the panel have... No. Well, it's interesting. It's worth us looking at it. But I think any other comments about our friend from Oxford there?
I do think that your point about case studies and examples in the UK is essential, and that's where, I mean, I was also amazed by the Americans have so you have entire cities that go into, rather than building a sewage treatment plant, they've got wetlands, which is really inspiring. I think that was a little bit around the work that I was trying to do, was to catalogue all these projects around the world to try and instill that step change. And I think maybe that's why I found such today quite important to, because I didn't know about, you know, your case study in Ashford, and I'm already kind of thinking, oh, I need to go see that.
Could I mean, just while we're on that vein, if we're having trouble getting people in positions of power who are using, you might say, old-fashioned thinking about water and sewage use and land and whatever, what are people, engineers being trained at nowadays at colleges and universities to do with water engineering and ecology?
Oh, it's been some time since I was at university, so I can't answer that entirely, but I think I did mention earlier actually that wetland design was looked at even as far back as when I was at uni, but people always looked at it in isolation and said, oh, well, if you wanted to treat all the water from London, or the wastewater from London, you'd need like half of Essex laid out as constructed wetlands, and it just takes up too much land. But I think what we're learning, like I said earlier, is wetlands are really good at being complementary with other systems. They don't need to be huge, and this is where pumps come into play, and you can sort of concentrate bigger flows in smaller areas. There's a lot of scope there for integration with wetlands and other technologies.
But I think this comes to, and Charlie, I'm really glad that you're here, because I think this comes to exactly the point of what you did in Ashford, which is not that far from Swale Cliff. It's coming, you know, for 19 million, a pipe was put that just to take the poo further out, when that's exactly what we were proposing to do, but the local councillors weren't interested, and neither was the water company. So I think that's where, I think as politicians, maybe you have more power than you might think you do. I don't know. Maybe we need more people from local authorities in rooms like this.
Yeah, good. Gentleman there.
Yeah, so, I mean, often we inherit stuff that's suboptimal and then we try and modify and improve it. But just hypothetically, if you were to take a completely blank sheet of paper and redesign our water system, what would it look like? And I'm partly thinking of when Bazalgette won that competition, the runner-up was Justus von Liebig, who proposed a cyclical model. Liebig did his best to persuade the king that Bazalgette's scheme, the linear scheme, would be a complete disaster and we'd lose the fertility from the soils and so on. But anyway, yeah, he lost that argument. Do you think maybe he was right? What would it look like if we completely redesigned the water system?
I think there are already examples out there. You know, Bazalgette looked to Paris and Europe for his initial ideas, and it's taken what's already been done. So the idea of sponge cities have been around since the sort of the 2010 mark, and it was the godfather of the sponge city is from China, and you know where they've seen massive urbanisation on a scale we don't see anywhere near here at the moment. And the blueprints for sponge cities are already out there. New Zealand are great at it, Australia, parts of America, where they're used to having these intense rainfall periods where they've suddenly got to slow and control the water, but also store it for later use. All the things we've talked about today is already happening in other parts, and it's now that we're seeing, you know, these issues that we've currently got, old systems, climate change, maintenance issues are stacking on top, and it's actually going to the forefront. These issues have always been there for 250 years. It's only now it's really in the public psyche, and it's not just a load of civil engineers.
But that's just one aspect, isn't it? That's separating the stormwater from the sewage, which makes sense. What else would change?
I think grey water recycling is something that should be possibly mandatory on new builds, because it seems ludicrous to me that we're still using chlorinated potable water to push our waste down the U-bend. It's nuts. So I think grey water recycling could reduce our water impact significantly.
Yes, gentleman at the end.
Thank you very much for the presentation.
I don't think the mic's on.
Thank you very much for the presentation. It was inspiring.
We still can't hear you.
Can you hear me now?
That's better, yeah.
Okay. Thank you very much for the presentation. It's inspiring, actually, knowing this forum. I think some of the questions I have actually about
Sorry, can't hear.
knowing that there are projects like, for example, where technology there. What we have to do on policy to make that work, in the sense that, sorry if you didn't hear, if Bill Gates have projects like this where the water quality coming out from buildings can come up almost to drink, pure, what we have to do on policy and technology and actually enforce companies that manufacture appliances to avoid this works that we do in buildings. What's the answer from yourselves, in a sense that you're dealing with
Policy,
this?
and I think it sounds like we know we have the engineering skills and the technology, and as I said, you know, the chemistry lesson that George taught us. But I think there is an issue of public and the policy, and it's the public are really getting worked up about it, and it's a question of the politicians, local politicians and national politicians.
But I also think it's about how we understand a problem. And I think I actually always found a lot of, I mean, I have a huge amount of respect for the money that Bill Gates poured into thinking about sanitation projects. And it definitely generated a huge amount of interesting ideas, from like things that are the size of a washing machine that can take poo and turn it into, you know, kind of a piece of charcoal. And I'm really into that kind of stuff. But at a global scale, and particularly for me at the time I was in India, I was like, in the places that I live in, these individualized, quite high-tech systems are just so far away from what we can do and achieve. And I always felt, you know, I'm from Venezuela, and my great-great-grandfather built a septic tank because he knew intuitively that everyone was pooing into the Lake Maracaibo in the city where he lived. And he knew intuitively that that was a bad idea. And he had seen some German book of septic tanks and intuitively thought, I needed to do this. And so this kind of thinking collectively, I think, has to be a foundational principle of how we deal with this problem. Because if we individualize it and atomize it, I think then, for one, it comes out of the realm of policy, you know, and thinking about local government, and it goes into sort of the few hands who can privately deal with it. And I think that's where we need to keep it as a collective problem that needs to be collectively solved. And I would prefer, and that's where, and then I lean towards these more natural systems over mechanized ones. And the role that I think mechanized systems can play is in hand. I mean, so I was amazed by this, seeing this Ethiopia case study where the state had just built all this housing but hadn't built the sewage infrastructure. And someone from a company had gone, I can solve the problem for you. I've got these sort of, they're very small footprint, and you just pump it in, really mechanized. But actually, and in that project that we were saying, in the recommendations that we were doing to the Ethiopian state, was, why don't you work in tandem? You can have wetlands working in tandem with these sort of highly mechanized systems. But yeah, because I just worry, if you put it onto the individual, I think you're going to make the problem worse. So I've never been a huge fan of very high-tech stuff. And I think that's what watching your presentations today has reaffirmed my belief in the sort of more natural systems. And then I kind of go, wow, why do we have the DEFRA problem? And I guess the only thing for me as an architect, and I'm thinking, is the work of like Finn Williams and going, let's flood the planning sector with amazing engineers. So we need to flood DEFRA with people like you two. I don't know, and I don't know how we do that. I actually don't know the answer to the question, because I feel like, as a sort of local citizen and someone who's been talking about this, I'm kind of constantly, it's like and I work really closely with this organisation called SOS Whitstable, who've been just relentlessly trying to fight to think differently about sewage, and some of the stuff that they've been said, oh, this is the only way forward is to sort of have huge tanks that hold grey water whilst we wait. I mean, this bizarre, absurd stuff. So I'm nothing.
Gentleman over there.
Hi, yeah, I'm from Oxford too, the bit that's flooding, and it seems to me, I'm an energy engineer, so it's not really my subject, but it's these combined sewers, and I'd be really interested to understand from Rhys what is the cost-effective, practical, economically viable way of solving the combined sewer issue, which is across the whole UK. Isn't that what's overloading the sewage works? Is all this rainwater? We just kept the shit as shit and put the rainwater somewhere else, which is much less of a problem. Isn't that the most cost-effective way? And I'm really interested in what you learned from Lambeth.
Yeah.
Thank you.
So I want to answer sort of both questions at the same time because you asked about the funding as well. So Thames Water know this is an issue, and they did have a tranche of funding which was released two and a half years ago now, the Surface Water Management Plan, and Lambeth, Matt Panow there, was very hot on it and secured just over £1 million worth of funding. And we also managed to secure funding for private jobs, which was per square metre. Anything you take from just flushing down the drains, Thames Water would give you £75. So your catchment area times £75, and you found out that actually you could pay for a lot more suds and fully green up a project. And they have a new round of that coming out in the next financial year. And yeah, it is about, you know, at the moment, especially when you look at London and most other built-up cities, the infrastructure was put in, you know, 100 plus years ago. To rip it all out and start again goes back to that, I'm just going to put in a giant sewer. We've got to think differently about the problems, and we've got to adapt to the climate that we're being given. And, you know, nature is the best engineer. Nature's been doing this. All of Georgia's stuff was based on nature principles with a little bit of engineering thrown in the mix as well. And that's what we need to do. Keep the water above ground, keep it out of the system. And people love water. That's the one sad thing about being a drainage engineer. You build stuff and it just gets put away and nobody ever sees it again unless you've got a real problem. And keeping it above ground, you know, making the drainage sexy, bringing it to life, and, you know, creating all these additional values.
In an area where it's clay, it's really hard to not put it in, and that's the Oxford problem.
Yeah.
You want to kind of, let's do a soak where you can't, because
Yeah.
it's clay,
But-
and there's only so much you can hold in water butts, because before we do great water, we need to do a lot more with rainwater, but all those systems are really quite expensive. You know, I personally do flush the loo with rainwater, but that's a bit Heath Robinson. It's not for most people to do that. But how do we?
So-
I'm interested in your £75.
Yeah.
What can we achieve with that?
So the entire, you know, London essentially is, you know, London clay. What we can do is slow that flow going in. So, you know, we can build up volume within the soil. So the rain gardens, the plants take a massive amount of, you know, they uptake a lot of water, especially when we're thinking about these sharp summer rainstorms where we get the bulk of the flooding. You can then slow the flow that's going into it. And we saw those hydrographs where you suddenly got that sharp spike, and the buzzword by Thames is slow the flow and Anglian water. So you're looking to just try and ride out that initial peak where it's going in unrestricted and flushing down there. So it's not about just dissipating it into the ground, it's holding it back as much as you can and trying to use it for essentially a bit of irrigation and keeping it on that surface and doing something nice with it as well.
Thanks very much. We're coming to the end of our time. I don't know whether our esteemed panel would like to make one last comment about this evening, any burning issues that they feel they would like to manifesto or not come out with as a last retort. I personally also feel, someone has just mentioned planning, and in one's experience as an architect, I get involved in planning a hell of a lot. And on big housing schemes that I see locally and around the country, they are told now they have to comply with all sorts of other regulations to do with energy and you know, solar and air source heat pumps, and don't use gas and things like that. But no one ever says anything about sewage and where that's going. They just assume that the sewage system can take it. And same sometimes with traffic as well. And so there is a great gap in the training, not just of possibly water engineers about this, but also with planners who actually have an important role to actually say no in future on trying to get development going. What do you feel?
Yeah, I think maybe returning to your question as to what, if we were to design a system, maybe not thinking back then, but going now with our problem, I think your provocation around, and I really liked how you framed it, is the Thames Tideway, is that the best that we've got? And I think listening to your presentations, no, would be my answer. And that's what I wish we hadn't done, Thames Tideway, and we could have done your Lambeth project and imagined every single borough that would be a sponge along the Thames, and how amazing would that be? And rather than spending, I mean, this is what just gets me so irate, that rather than spending, let's say, my case study, £19 million to build a pipe further out to sea, we could have £19 million to have a walkway through a reed bed for a fraction of the price, you know, which would have been a better place already now. You know, if you're walking your dogs in Swalcliffe, you don't want to let them off a lead because they're going to run into actual water with shit in it. How amazing would it have been for a fraction of the price? And that's, for me, this is what kind of is what I was hoping to take away today, is that what's the barrier? And I've learned something around DEFRA, like what's the barrier? Why are we not doing something that's cheaper and better? Like that's, I just can't get my head around this. And so, yeah, I think I've definitely learned a barrier to that vision, because that's the vision that I want, sort of really empowered, beautiful public spaces that simultaneously deal with our water.
George, any final points?
Yeah, I just add to that, and to pick up on what I was saying about that particular case study with the DEFRA guidance. The chap at the water company, he said there's only so much he can say, because they're like, oh, you're just a water company, you're going to say that, we're not going to listen to you. And I think the problem is that DEFRA and the water companies can sometimes sort of act in a little bubble, and they don't listen to anybody else, but everybody's got a vested interest in their local catchment. And there are such things as catchment partnerships. And this chap said, if we could have a bit more of a voice from those people, and they want to know, what are you doing in this catchment? And then they'll be the first to call out, well, wait a minute, if a wetland's an option, we want to have that, please, because I walk my dog near there, and that'd be quite nice to look at, and it's going to do something for wildlife.
Yeah.
So I think we need a bit more action in the catchment.
Good. Action in the catchment. Bruce, anything?
Yeah, if you do what you've always done, you're going to get the same results. As engineers...
And your Benjamin Franklin quote. Yeah. I thought that was so good.
As engineers, we love looking back and going, oh, what did we do last time? Or, oh, you know, I've got the rules to this, I know what's going to happen. And it's difficult. Doing these things is difficult. It's not just off the shelf, big tank, under the ground, jobs are good. And
yeah.
It is, you're having to push the boundaries, push different people, councillors, highways, adoption, maintenance. And it takes time, and it takes pressure, and it takes blood, sweat and tears. And it's just building up this momentum, and it starts with things like these, and it ends with beautiful wetlands, suds in the streets, no big pipes, all those sorts of things.
So in a way, you could say the problematic invention was the tube or the tunnel, really.
Yeah.
Shoving it, as you said, underground. Let's forget about it, and let's get rid of it and whatever, because they didn't treat the sewage, and they didn't want to see the sewage in the Fleet, which was then just a culvert. And anyway, there we go. Look, I think we better finish now, but thank you very much, audience, for being here, and I'd like to thank the panel for their really engaging and spirited talks. And we haven't solved anything yet, but we've got quite a few ideas, I think. So.
Thank you. Gonna be now.
Oh, that was good. Well done.
That's all right.